The question over here is minimum cost to convert the string. You're given a source string and then a target string, and how would you go about this conversion? The solution is your minimum cost, so the cheapest way to convert this string. So do you go directly or do you go via a string in the middle? So to go about this question, there are only 26 nodes because there are only 26 characters in your alphabetical order. So you are running your Floyd-Warshall algorithm to get the cheapest conversion between every pair of letters and then sum over the positions. So in this, you have a 26 by 26 grid, which is your distance grid. This is how I have declared it, and you're going to start by initializing it to infinity. Over here, also notice that I've used list comprehension. Then you have for I in range 26, and then you are setting your distance of I to I equals to 0, which means turning A to A requires nothing, so you just set it as 0. Then you are building a graph. So you have OCW, which is your original, then your changed, and then the cost. And then this is how you build the graph. And then ord O minus 97, what this does is that your ord of A, so this highlighted value is equals to 97. So when you subtract 97, it means A is 0, B is 1, C is 2, so on and so forth. So this is how we index into the matrix. Then we are checking if W is less than distance of U to V. So this guard will handle the duplicates. Now in the input, we can have the same pair twice with different prices. So for instance, to go from A to B, it can be 10, and then A to B can also be 3. Now over here, we need to consider the cheapest assignment, right? So we are just checking that a plain assignment would keep whichever is the last. So if A to B 10, if A to B costing 10 is your last value, then this would be the assignment in your graph. However, over here, you're running a check that whichever is the value, if it's the lowest one, then you reassign it. Then this bit is your whole Floyd-Warshall algorithm. This is your core. So you have an outer loop, your K loop, which is going over 26 times. Then you have I loop, you have your J loop. So you have 3 loops. What essentially you are checking is if you are going from I to K and then K to J, if you go from I to J via K, if this is less than directly going from I to J, then you reassign your distance of I to J to this path, which is when you go through K. So you're just checking if going over K is the cheapest path, then you reassign your distance I to J via K. This is what you're doing. And then you are summing it up by saying that total, you're setting it to be 0. Then you're zipping up your source and the target. So source is A, target is A, source is B, target is C. This is how you zip. This is what it means. Like you basically zip the two values. Then you are again setting your distance. The same thing, minus 97 is how you index the grid, index into the matrix. And then you were saying if D is equals to float of infinity. So if there is no possible path, then you just return -1 because the whole conversion is impossible. There's no path to its target. Then you are adding all the paths possible, so all the cost, you're adding it up, and then you're just returning the total. So this is the whole algorithm.